All right, so I think it's time to start. Welcome to my presentation. In last AppSec in London, I wanted to show you that pentesting iOS applications without jailbreak is possible. And in this year, I wanted to change the sites and show you how to build and hack modern iOS applications. So my name is WOJCIECH REGULA, and I am a senior IT security consultant at Securing. I'm mostly focused on iOS security and Apple product research. If you are interested in this topic, you can visit my blog. So the link is on the slide. And some of you may know me from OWASP security knowledge framework that I contributed to. All right, so I introduced myself. Now I want to know something about you. So security division and builders, hands up. All right. And programmers, hands up. Okay. And iOS developers, if any. All right, so there are iOS developers. It's cool. All right, so we do not have time to speak about everything in 30 minutes. So I'll cover selected vulnerabilities that I found during conducting penetration tests. The extended version of this presentation will be available on my Twitter, so if you wish to see the full version, you can check it on my Twitter. All right, so the agenda. At first, we are going to talk about iOS platform myths and the reality, so we will be a myth busters. Then we'll go through selected problems and solutions for this kind of bugs and myths. Then I will be presenting you the new Apple WWDC features that may help improving your application security. In the fourth point, my new library, iOS Security Suite, but I won't spoiler it at this moment. And at the end, as a summarize, I give you short and long-term things to implement in your iOS applications code. So, the part one, platform myths and reality. In this section, I wanted to show you that we cannot rely on Apple platform as a 100% secure. So the first myth that their Apple's review is 100% reliable, and as you can see on the slide, guys from Guardian Mobile Firewall were inspecting a malicious application with a malicious activity, and they find out that this application had a need bypass for Apple's review. And as you can see, there is a method called isCupertino. And as we all know, Apple tests and does their review in Cupertino. So if the application was run there, the malicious activity were hidden from them. So they didn't find it. So as you can see, some Apple's review bypass happen in the wild. The myth two, there is no jailbreak for modern iOS versions. And no, it's again not true. We have uncovered jailbreak that is even open source. You can look into the details of their code on GitHub. So even iOS 12, as you can see, is covered, some of this version, of course. And the myth three, no jailbreak means no reversing applications. Whenever you try to download the IPA, the application package from App Store, it's encrypted using Apple DRM. So if you want to inspect what's inside, you need to have, or in the past, you need to have physical device, the jailbroken physical device, because you had to install the application and dump the decrypted version, right? And things had changed because now we have a tool called Corellium, and Corellium is a full virtualization of iOS device. So it's very interesting because now the process of dumping iOS applications will look like this. You just visit their site, register, pay for the license, and then you create a new device. So it may be, for example, iPhone 6. You press OK, and you just tick the button whether you want this device to be jailbroken. And then, as shown on the screenshot, you have an SSH connection. So you don't need a physical device anymore if you want to dump the decrypted versions of your applications. It's pretty cool. So we're going to part 2, this secure development, and before starting developing a modern iOS application or just an iOS application, we have to think about the architecture and choose the programming language that we want to use. So in iOS, the situation is very simple because we have Swift and Objective-C. And Objective-C is only let's say a wrapper on C, because whenever you try to compile Objective-C codes, it's at first the code is translated to pure C and then compiled. So the vulnerabilities that you know from C will also exist in Objective-C. Swift is the modern Apple language to develop the applications. So in Swift, for example, if you meet integer overflow in your application, it will cause a runtime error. So no vulnerabilities like that. In Swift, you do not have direct memory access. Of course, you can access directly the memory, but the methods will be prefixed by unsafe strings, like on the example shown to the slide, unsafe pointer, for example, right? And the vulnerabilities like format strings won't exist in Swift because we have, you know, like in every modern programming language, string interpolation, right? All right, and when developing iOS applications in Swift, there are a few myths that I wanted to bust. The first one is that Swift auto-obfuscates itself. It's not true, guys. I had a client that needed to be compliant with mobile application security verification standard, the OWASP one, and in the category 8, in resiliency requirements, there is a check called obfuscation. And my client claimed that they did not do anything with it because Swift auto-obfuscates itself. And I wanted to officially bust this myth. There is no obfuscation. There is a mechanism called name mangling that you probably may know from, for example, programming in C++. So, as an example, we have a test class with one instance variable constructor and 2 methods. The functionality is just a simple clock. It every 1 second will print incremented number by 1, right? And when we compile it and use nm on the binary, you can see this whole weird strings. These are the symbols of this binary. And as you can see, they can be reversed or translated to the human readable ones. So at first you can see that underscore dollar indicates that it's a Swift symbol. Then you have length of module name like this. It can be reversed, right? Apple even provided an automated tool to do this. So if you pass the previous grep to XC runs with the mangle, you will see the symbols in human readable version, right? All right. And another myth Swift methods cannot be dynamically changed. And no, it's not true. We can use Frida. If you don't know what Frida is, it's just the dynamic instrumentation toolkit for developers. So all we need to do is just hook the Swift symbol. It's as simple as that. So example of Frida code that we will be using in the demo. So we hook this symbol, and whenever it returns a value, we will intercept this and change the value to lead, right? So it's now live demo time. All right. So at first I'll open this binary, and as you can see, it's just a regular clock. And now with this parameters, we'll open Frida with the script that I showed you before. And as you can see, the number now is always lead, right? So we changed the code execution flow, and we changed the return value. Okay. So takeaways from this section. Swift protects your application against binary vulnerabilities, the typical ones, and enforces deliberate usage of insecure methods like showed before, unsafe pointer. There is no obfuscation. If you want to make your application to be reverse engineered harder, you can use, for example, Swift Shield that is free, open source, and works well. All right, so data storage, the next category. And when talking about the data storage, we have to consider the data that shouldn't be on your devices. You know, and this can be API keys like Firebase private key. I saw that a few times in the wild. SSH keys, cloud credentials, or even test accounts that work on production environment as well, right? And when we know which data shouldn't be stored on device, there are different type of data, the sensitive type of data that should be stored on device, like, for example, session tokens, right, that should be stored. And the places that this kind of data shouldn't be stored are info playlists, user defaults, regular files, or this sensitive data maybe even hard-coded into binary. Especially, I found a lot of times when conducting penetration tests, the cloud credentials hard-coded into the executable file, right? And when we are talking about the data from this category that shouldn't be on the device anytime, you shouldn't store it in the keychain, right? The keychain is secure mechanism to store data, but if some data shouldn't be on the device, it shouldn't be stored even in keychain, right? Okay, so the CUSA, famous iOS security researcher, shared his research where he shows the different types of spyware, and as you can see, there is a lot of spyware on iOS that, as a technique, use iCloud backup. So when we are developing iOS application and we need to store some data in files, we have to know which of this data, which types of this data will be backed up into cloud, right? So these are directories that are backed up. So, for example, documents, library application support, library preferences, and any other directory in library without caches. And of course, temporary directory won't be backed up into iCloud. Okay. And the WWDC feature that I wanted to show is credential provider extension. So now you can use iCloud Keychain and your password managers also in your native application. That's really cool. But if you want your application to be optimized to work with these extensions, it's a good practice to add UI text content type to your text inputs. So the password managers will be better know which input they should autofill. Okay, and the architecture and the takeaways from data storage are: always check if any sensitive data is stored in your APA. For sensitive data stored in keychain that you don't want to be saved in iCloud, use this weird string, ksec attribute accessible when, with this device only suffix, so they won't be backed up to iCloud. If you need to store some other sensitive data in regular files, you may consider the UI key data protection API. And of course, the last takeaway may be optimizing your app with credential provider with adding this UI text type, right? So now cryptography, the vulnerabilities that we found in this MAS/VS section are, for example, insecure token generation. And I'm going to show you that on Bear example. Bear is an alternative to Evernote. It's just about noting your thoughts. So Bear had a functionality both on macOS and iOS that via URL schemes allowed to retrieve a private note from Bear, from your installed instance of this application. And it's pretty sensitive, right, to retrieve sensitive nodes. So Bear developers decided to authorize this operation with user token. So I wanted to show and investigate how this token is generated. So I opened Hooper and loaded it into it. This is a pseudocode. I rewrote it to Objective-C version. And without reading this code, you can see here we create a new date. We use MD5, some bit shuffling, and here we go. Here we have a token, right? So it can be easily brute force. So I did the same, and I wrote the full exploit and I retrieved the private nodes from Bear. If you are interested in details of how I wrote this exploit, you can read it on my blog. So I'll give you a few seconds to take a photo. All right. Okay, I think everyone took the photo. So automatic strong password as a feature of last WWDC. So the mentioned before autofill now can create natively passwords connected to your domain and apply a specific password policy with providing such string. So you just type required upper and the policy you want to apply on the passwords. And takeaways for developers from cryptography are: please do not create your homemade ciphers since it's very hard to do it securely. And treat your encryption algorithms as a public, because your application, as said before, can be easily reversed even if you restrict the iOS version to the latest one. You can use Corellium and just decrypt your application and know how your secret algorithms were made. And if you need to deal with cryptography and AES or RSA, now you can use sec key create encrypted data, and it's native mechanism in Swift, so you can use natively both symmetric and asymmetric cryptography. And you can now enforce your password policy using a native mechanism without using any other third-party libraries. So now we go to network communication and the selected vulnerabilities here. So avoid HTTP. It's an encrypted channel. We all know that. I don't think I have to explain this on this kind of conference that you shouldn't be using HTTP. Use HTTPS instead. And from iOS 9, Apple introduced App Transport Security, which is a mechanism that by default will disallow the HTTP unencrypted connections. So developers in practice usually disable this mechanism, and it's really not a good practice. Apple knew why they need to implement such mechanisms to protect your application, so please try not to turn it off. And if you use HTTPS, you should make sure always if your certificate is trusted. And not checking if the certificate is trusted is a really common case when developers implement certificate pinning, and when sometimes they stop using certificate pinning, the mechanism that will not check the validity of the certificate is still in the application. So, for example, Twitter had a similar bug. They paid for it over $2,000. So as you can see, Twitter iOS fails to validate server certificate and sends auth token without checking if the certificate was right. Okay, and the next category that is platform interaction. So when talking about platform interaction, I mean inter-application communication, because every application in iOS that you will install from the App Store is sandbox, right? So in iOS we have XPC, Mac messages, URL schemes, AirDrop, and Clipboard, but please do not use Clipboard as an inter-application communication mechanism. The Clipboard can be easily intercepted and modified. We all know that, but I really found such bugs in pen tests. So in iOS, we should use these two kinds of mechanism. So URL schemes, the most important thing here is checking the sender, because in most cases we can whitelist the applications that will be communicating to us, right? So it's just about whitelist and checking the sender. And the bugs from the from the real world, for example, Grab both on Android and iOS version via this URL schemes had a problem with information disclosure, and as you can see, they paid over $7,000 for it. Again, Twitter. iOS application can establish FaceTime calls without user permission. Maybe a little bit less bounty, but still a neat bug. And the takeaways from here are check if a message comes from the expected sender list. So always try to whitelist the senders. I don't need to probably mention that the parameters that are passed should be validated by you. And the third tip here is if the message that you retrieve from URL schemes is passed directly to the web view, please check it twice and check what the web view has permission to, because there were a lot of bugs with it. And the next section, code quality. So the three main points are easy here. Try not to use deprecated APIs. Libraries that you use in your iOS application also may have vulnerabilities. And if you use packet managers like CocoaPods or Carthage, please do not use fixed versions there. I know it's very hard, but there were a lot of bugs with it. As an example, AF networking in this version allowed to perform a man-in-the-middle attack because it failed to verify the SSL certificate. So as you can see, if you have hard-coded via, for example, CocoaPods, this AF networking with this version, you're still vulnerable. And during conducting penetration tests, I really commonly see the applications that have such old versions like this AF networking. So try not to hard code the fixed versions. And Apple in the last WWDC deprecated the UI WebView class, and they were right. Because by default, UI WebView allowed to access your local files via this file handler. And by the way, WebKit WebView also allows to retrieve your local files from the application container, but it's not by default. You have to turn on the specific flag. So, and what's the problem with it? If attacker was able to exploit a cross-site scripting vulnerability, the attacker was also able to steal your files. And now, some examples from Apple applications. So as you can see, I found similar bug in dictionary, in macOS dictionary. It's just a simple application that will translate words from one language to another. But the interesting thing was that they at first used UI WebView, and you could insert your own dictionary to the dictionary application. So I created a malicious entry, and as you can see, the code is very simple. It's just using AJAX. It retrieves the etc password and sends it to my server. And the demo time, I'll show you how it worked. So on the right, dictionary application, on the left, terminal. I open netcat with listen parameter, and now I press the malicious dictionary, try to search for something, and boom, etc password was sent directly to my server. There was also a similar problem with help viewer, but I don't have time to explain it to you. If you are interested, come talk to me after the presentation. And Lucky Hart from Google Project Zero found this too, so kudos for him. And an example from non-Apple applications, Yahoo iOS version had a similar problem, and attacker was able to, as you can see, retrieve full cookies from the applications, and Yahoo paid for it over $3,000. Okay, so now the latest category that I wanted to show you is resiliency requirements. So in this section, we are going to talk about anti-tampering, and anti-tampering is kind of additional security layer that you may be interested to implement it to your application. And this is especially for those who just don't want to be their code tampered with, or consider malware as a risk, because usually malware will at first jailbreak your phone and then do some malicious activities. And there are, of course, developers that just need to be compliant with mobile application security verification standard and just, you know, check the column in anti-tampering. So I prepared a special library for it, iOS Security Suite, that's now in pre-release stage. It's available at GitHub, but the features that I wanted to say that it's in pure Swift, so no legacy objective code in your applications. It will detect the new jailbreaks with new indicators. It will check for attached debuggers, or even will find tampering tools like Frida, Needle, Passionfruit, and any other common tools. And also it will check if your application was run under the emulator. So if you are interested, there is a QR code to the GitHub page. I released it on MIT license, so feel free to use it for free. All right, a few seconds to take a photo. Okay. And and the summary. So the most common vulnerabilities that we find in modern iOS applications are sensitive data without any protection that may be backed up, the API keys, cloud credentials, working on production test accounts, the network issues like HTTP connections, poorly protected URL schemes, or fixed library version with commonly known vulnerabilities. And the recommendations for developers, in short term, you should try to optimize your application to work properly with password managers and autofill. And if you are developing a high-risk application, you may consider applying additional anti-tampering checks in your app. And in long term, if you used UI WebView that I showed you before with these vulnerabilities, you may need to change to WebKit WebView. From the last WWDC, you now can use native password policy in your application, so no more third-party policy enforcers. And if your application is written in Objective-C, it's now a good time to start thinking and considering migrating it to Swift. I know it can be painful, but now Swift is, I can say it's stable, so, so it's a good time to think about it. All right, so based on our experience in most applications that we test, vulnerabilities exist. And in my opinion, and it's only my opinion, most of the vulnerabilities can be fixed by security-aware developers. But we're only humans, right? And even security-aware developers may miss something. So if you develop a high-risk application, I would recommend you perform penetration tests. Security is very important here. So for everyone who leaves their business card, I will send this presentation directly to their email. And for now, it's all. Thank you for your attention. I'll take a photo with you. It's my tradition. All right? If you have any questions, feel free to ask.